Hey class, I'm going to work on a couple problems in this video. Problem 9.36, page 314, and 9.38 on page 315. Okay, so 9.36, we've actually worked on this problem in class already, but that's okay, we'll do it again. Manufacturer of aspirin claims that the proportion of headache sufferers who get relief with just 2 aspirins is 53%. What is the probability that in a random sample of 400 headache sufferers less than 50% obtain relief? So let's just do that much. Great. So one of the hard things about these problems is to figure out what approach we're even supposed to take, right? So this is actually a binomial experiment. You can kind of think about that this way. You can say, well, what can happen? What are the possible values that could happen in the sample, right? I know I have a sample of people. What could happen? Well, they could either get relief or they could not get relief, right? So there's only two possible things that can happen with our sample, with the people that we sample, or the things that we sample, right? So if there are more than two, if there's a whole bunch of things, then we know right away we're dealing with averages, not proportions. We're dealing with averages, and then we would take a different approach. But here we're dealing with proportions, right? A binomial experiment, one of two things. Okay, so if we know that, then we know we have to deal with p's and p hats, and the standard error that's specific to those, right? So don't get that confused with the first part of the homework, which was using x bars and sigmas and stuff like that, because that's a different type of problem, right? So those are not binomial experiments. Because this has a really big sample size, 400 headache sufferers, we know we can just assume this is normally distributed, right? The proportion is normally distributed, meaning that the percentage is normally distributed. If this were not so big, we would probably want to change this, and instead of looking at the percentage, we want to look at the whole numbers, right? So say, for example, we only tested 10 people, or maybe 15 or 20 people. Then the question we could use the binom dist, but instead of asking the percentage, right, the percentage people, we would ask, what's the probability of, let's say, 10 people, or the probability of 12 people, or 12 or less, or something like that, right? This question is asking something different. It's asking for sort of the probability of less than 50%, right? So the first thing that I like to do is when I think about these problems, let's see if I can draw this, to sort of draw this out, right? So if we were to draw this as a normal distribution, like something like this, and I always like to think about what is sort of right in the middle, right? What's the mean? Well, and also think about what's expected. What's sort of we talk about the expected value is also the mean. Well, in this case, what's expected is we also think about as p, right? For this kind of problem, p, and in this case, p equals 0.53. Now, why do I say it equals 0.53? Because this is what's expected. This is what they told us was supposed to happen. 0.53. So there's 0.53. We went out and sampled. And what did we get? We found 50%. So I don't know where that is yet, but it's over here to the left somewhere. Let's see right here, and it's 0.50. And what is the question asking us? So this is just to help us understand what side of things that we're supposed to be doing. Less than 50% obtain relief. All right, so that's just this side right over here, right? So we know that we have to find less than, which is just what the norm dist function does for us. So we're real happy. So with this, we know we got a normal distribution with 0.53. Right, as our mean. 0.50 is what we got. So we have two things. What we got, what we expected to have got. The only thing that's left is this third standard error, right, or the standard deviation. But in this case, this is a standard error because we're applying, a binomial distribution to a normal, a binomial experiment to a normal distribution. In which case, we need a standard error. So let's do this. All right. So this is what when I set up these problems. I would put this sort of a p somewhere, maybe an n. So what's our p? Well, we sort of already figured this out. Our p is 0.53. This is what we expected to have happened. Our n, where our n is the number of people or things that we actually went and saw or recorded doing the binomial experiment. Remember, the binomial experiment was one of two things. Either you had a headache, or you either got relief from the headache, or you didn't. Right? So how many people did we actually look at? 400 people. 400 people. All right, and then p hat is what we actually observed. What we observed from our sample of 400 people, 50%. All right, so the only thing that's left then is the standard error. So I'm going to put right here, standard error. And the formula for standard error for proportion, right, because we're dealing with p's here, proportion, was something like square root of, what was it, p times 1 minus p over n. Alright, so how do I do this in Excel? Equals square root sqrt. And then here's p, I'll point up to p, times asterisk 1, and then in parentheses 1 minus p, and then divided by the slash n is right above that, right? I just wrote down n right there. There's my answer. Alright, so now I want to know the probability that p hat is less than 0.05. That's exactly what I drew over here, less than 0.05. Alright, so how do I do this? Well, it's easy. I just use this norm dist function, right? Norm dist, oops, equals norm dist. And my x is what I got. Well, that's the p hat, right? That's this other point right here, p hat. Our mean, comma, mean, 0.53, comma, standard deviation. Well, I use this standard error that I just calculated, comma 1. Cumulative. So there we go, 11.45%. That's it, right? So that's all that is for that part of the question. The second part says, if 50% of the samples actually obtained relief, what does this suggest about the manufacturer's claim? Well, we would say that the manufacturer's claim is a little bit skeptical, but not too far off, right? 11.45%. And we could find another, if we wouldn't sample this again, and he's right, there'd be only 11% chance that we would find something as low, let's see, that number or lower from another sample, right, if we were to go sample again. So that's a little bit skeptical. We might be a little bit skeptical. All right, so the next question is repeat part A using a sample of 100. So there's several types of these kinds of questions in the homework. If you set it up this way, all I have to do is type in 1,000 right here for n, right, and then see what happens. That's it, right? So everything else is updated if you pointed it and done the way that I would set things up. So let's just do it again now, just so we get a little bit more practice. But that's the easy way to do it. So let's just put it down here. So what's our P? P is still 0.53. What's our N? This time our N is 1,000. When we talked to 1,000 people, we had a much higher sample. What's our standard error? Well, it's still this crazy formula. Square root of P times 1 minus P divided by N. Right now it's much smaller, 0.05. Our P hat then is still 0.5. I didn't say anything about changing P hat, just said I just got to change the samples. And then this norm dist function, same way, norm dist. What I got is P hat, what I expected, P. Standard deviation is actually standard error, and then 1. 0.02. Is that what I got when I changed it up here? No, I'm skeptical. 1,000. Yep, same thing. Alright, so what does that mean? Well, it means if I have a much bigger sample, then I can be much more precise. So now, if I have another sample of size 1,000, there's only a 2.8%, roughly 3% chance that I would get something that small. So now I'd be very skeptical, right, of the manufacturer's claim, if I were to be able to get these results with a sample size of 1,000. All right, so that was supposed to be 9.63. I think I put it in the 9.38, 9.36, 9.38 tab. That's right. I'll change it here. So this one is 9.38. So I actually haven't read 9.38. So here we go. A commercial for manufacturer of household appliances claims that 3% of all its products require service call in the first year. Consumer Protection Agents Association wants to check the claim by surveying 400 households that recently purchased one of the company's appliances. What is the probability that 5% require service call within the first year? Okay, so that's all we really need to know for the first part. So again, if I didn't know what type of question this was, I'd have to think, okay, we're sampling people. How many people we sample? We sample 400 people. And what is it we're measuring? What is it we're asking? Well, we're asking whether or not, let's see, wants to check the claim, 400 households recently purchased. What is the probability that 5% required a service call within the first year? So we're just going to ask them, we're measuring if they had a service call. That's it, right? So they either had a service call or they did not have a service call. So this sounds like a binomial experiment, one of two things. That's it. So if instead we measured like how often they use their vacuum, like the hours, or if we like went and weighed their vacuum cleaners for excess dust or something like this, that's a continuous variable. It's not one of two things, and then we would use the average type of things. But we're dealing with proportions in this case, one of two things. So hopefully start thinking about these questions about what's the right approach here. So if that's the case, then we care about what we care about P, N. We have to have a standard error, and then we have to have P hat. All right, and I'm going to draw a little bit just so I know what's going on. So we have a pretty big N 400. So right away I'm going to say, well, if we have an N of 400, then I'm pretty sure we're going to be able to use a normal distribution. So here's our normal distribution. And by the way, so we have a normal distribution of proportions, right? So these are proportions, not of the counts, not like the counts of the number of houses. We're actually just dealing with the proportions, right? So that's why we have put the P down here. We don't actually put P times N. We don't put the expected value there, right? Which is what we learned about the other in previous times. We actually put P. This is the distribution of P, actually P hats, right? But what is our P? So this is the claim. The manufacturer of households claims that 3%. So this is 0.03, just like that. And then we want to test what's the probability that more than 5%. So that's over here somewhere. 0.05. And we want more than 5. So that's this side of things, right? Okay, more than 5. Okay, so we know how to do this problem. Or at least we know what's going on here, right? So we have what was expected, what we actually got, or what we're asked to consider in this case. 5% what we're asked to consider. This is what's expected, what was actually given, was told to us. So 0.03. And then we go and sample how many? 400 people, 400 households. So the standard error, that's the same as the crazy one. We just did square root of P times 1 minus P over divided by N. Just like that. And then P hat is what we're supposed to consider. It's not really what we got, but we're asked to consider that this is what we got. And what's the probability of this happening? Okay. So now how do I do this? Well, since this is the right side, this is a 1 minus norm dist, right? So it equals 1 minus norm dist. Norm dist. X is what I got. That's P hat. The mean is what I expected to get, P. Standard deviation is our standard error. And 1 is our cumulative. So pretty small, 0.009, which makes sense. Our standard error is very small, not even a full 1%, right? So if I go 3% away from here, I'm at what 3, 4, 5. Yeah, this is more than 3 standard deviations away. So we're pretty sure that that's not really likely to happen. According to our calculations. Okay, so what's the next part of this? What is the probability that more than 5% require service call? That's what we just found out. What would you say about the commercial's honesty if a random sample of 400 households, 5% report at least one service call? We would say that they're almost certainly dishonest, right? So it's not even a 1% chance of this happening according to our sample. If we had a sample, this is where the results came. All right, so hopefully that helped with doing your homework. These are fairly simple to set up once you sort of think about how they're doing. Okay, that's it.